let's try out this problem. Okay, so during free radical halogenation, the reason for the anti-Markov addition is that A, hydrogen is more electronegative than carbon. That's not true. Hydrogen is way over on the left. Hydrogen is more electropositive, so we can get rid of that one. B, the sheer size of the carbon atoms is better able to stabilize the secondary radical as opposed to the primary radical. That's kind of iffy. It's not clear why size specifically should matter. That's kind of a shady connection. For example, iodine is bigger than carbon, and iodine is not going to stabilize the radical. And electronegative groups are not going to stabilize the radicals. So that's not really clear. We can sort of circle that one tentatively. Let's look at C. Alkyl groups are more capable of hydrogen donation. Or alkyl groups are more capable than hydrogen of electron donation. Okay? Alkyl groups are electron density donating. And we're going to talk more about that in the next lecture. So stay tuned for that. Okay? That's a good answer. I like that one. For D, the primary radical is slightly more stable and short-lived than the secondary radical. No, it is more short-lived because it's less stable, so that one's out. And again, B, not so hot of an answer. It was maybe plausible, but not really, because there's a lot of trends that might violate that. So our answer here is C. Alkyl groups are better electron density donators. That's the reason why the tertiary carbocation is more stable. It has more alkyl groups which are electron density donating. It's more stable than a secondary carbocation. Secondary carbocation is more stable than a primary one. The more alkyl groups you have, the more they're going to stabilize positive charges. But only positive charges. They're not going to stabilize negative charges. In fact, they're going to destabilize negative charges. And again, we'll talk more about that in the next organic chemistry lecture. The last kind of reaction that I wanted to discuss for this lecture is the hydrogenation-dehydrogenation reaction. This is a relatively basic reaction whose mechanism you do not need to know, but you should be able to recognize this. Okay? Hydrogenation reaction is a reduction reaction. You add H2. You're adding hydrogen atoms. Dehydrogenation reaction removes hydrogen atoms. It removes H2. So for example, this saturated fatty acid can get dehydrogenated into a monounsaturated fatty acid. And conversely, I can hydrogenate the unsaturated fatty acid into a saturated fatty acid. Note the nomenclature that I mentioned is kind of outdated and not particularly useful, but you'll still see it a lot. Cis, they're both on the same side. Trans, they're on opposite sides of the alkene. Okay? Natural fatty acids are the cis fatty acid. They have that kink in their direction, and so they more resemble, they're more fluid, and they're easier to deal with in our membranes. And we actually have enzymes to consume them, to digest them. Trans fatty acids and trans fats, you'll find them synthetically being produced due to catalytic hydrogenation, dehydrogenation reactions, because metal catalysts are not stereospecific. They'll be able to produce generally cis and trans fats. And so when you produce these trans fats, they resemble saturated fats a lot, right, in terms of their shape. And we don't really have enzymes that know how to deal with these. And so that's part of the biologically problematic issue with consuming trans fats. So that's all that I wanted to cover for today. Now, what you saw in this lecture was a lot of foundational work. In the next lecture, we're going to dive deeper and talk about the individual types of functional groups and the reactions that they can undergo, and look more at analytical methods, functional group physical properties, understanding how a lot of these organic molecules are going to interact in solution. And so we'll see more of that. This lecture is really critical, though, because it acts as the foundation on which we can actually build the rest of the organic chemistry content. You have to know the basic foundational principles of reaction. You have to know that like the back of your hand. Under no circumstances should you be confused by what's the electrophile, what's the nucleophile. You must know these things because otherwise everything else crumbles. You can't build a house on a crumbled foundation. Okay? So you have to know those things. You have to be able to identify molecules when you see them. You have to be able to identify names when you see those molecules, right? You have to understand why some reaction would be favorable over others in terms of the stability of the intermediates, the favorability or the difference in the nucleophilicity, right? A lot of these things were really, really key. So we're going to dive deeper into the next lecture, and I'll see you then.
For most students, and maybe you too, the CARS is the hardest section on the MCAT. It may feel like it's one of the few remaining obstacles between you and the medical school of your dreams. But as you try to prepare for the CARS, you find there is a never-ending stream of conflicting tips, strategies, and plans, none of which seem to actually help or show any results. If you feel frustrated, overwhelmed, or lost when it comes to the CARS, if you're looking for a CARS expert who has helped thousands of students achieve their MCAT CARS goals, then you found your solution. Testing Solutions MCAT CARS Bootcamp. Founded by Nick Zahner, a current medical student at Stanford with a master's degree in philosophy of religion from Harvard, Testing Solutions' approach to the CARS is revolutionary. Testing Solutions CARS Bootcamp provides day-by-day, step-by-step instruction that teaches you the techniques that produce ultra-high MCAT CARS scores. Instead of wasting your time with the needlessly complex filler that other companies try to sell you, Testing Solutions' approach to the CARS is based on the principle of minimum effective dosage. There's no wasted time, just the minimum amount of effort that is required to get you the results you want. With over 500 4.5-star reviews on Amazon, Testing Solutions CARS Bootcamp is the most trusted, proven, and effective CARS course available on the market today. You will have access to Testing Solutions' 180 meticulously designed CARS passages, the largest CARS practice library offered by any MCAT prep company in the country. Our passages are regularly rated by users on Amazon, Reddit, and SDN as the most accurate non-AAMC CARS practice passages available, consistently rated higher than Exam Crackers, the Princeton Review, Kaplan, and Next Step. Unlike some companies who prey on pre-medical student fears by charging outrageous amounts of money for their mediocre at best practice materials and courses, Testing Solutions will always charge a fair price for an amazing product. Because after all, we're not like the other test prep companies. We're aspiring doctors just like you, only a little further down the path. Let us help you do what we've already done. If you're not happy with your CARS Bootcamp for any reason, we offer a 100% money-back guarantee, no questions asked. You've got nothing to lose and the CARS score of your dreams to gain. Don't be one of the people who write us each week saying they wish they had found our MCAT CARS Bootcamp sooner. You don't have to struggle with the CARS any longer. Sign up and get started today.